Hello, this is Timothy Wood with the Citadel Civil Engineering Department, and in this video, I hope to walk you through engineering problem solving within the context of three models. So reality, our mental model, and our engineering and mathematics models. And so with that, I'm going to jump straight into it. Our first model we want to be able to think through is that of reality. As engineers, it's our job to shape reality. Now, turns out reality is kind of jaggedy. It doesn't really care how you feel about it. This is things as they are. But this is where the engineer wants to come up with his and implement his or her engineering applications. Okay, so as an engineer, we're working to find solutions to solve problems, engineering applications. In order to engage with reality, though, we have to be first students of reality through observation. So by observing reality, we learn about what it is, and we develop our second model, which is our mental model. Now, our mental model exists inside our head, and our mental model is rather than things as they are, it's us thinking about them. So it's going to tend to be qualitative and intuitive. And all of you have a mental model like this. For example, I'm sure you've played basketball, shooting hoops, and you've gone up for that shot and you let the basketball go, and the moment it leaves your fingertips, you know that not only is it not going to go in, it's going to like airball, right? And you didn't do any calculus to predict that reality. Rather, your mental model told you what was coming. And when we think about this mental model, what we're often going to be doing is drawing sketches and diagrams to illustrate our engineering judgment. And it's this judgment that is critical to how an engineer works. And in fact, I would say that this mental model is where the engineer makes his money. It is your ability to look at the world, to observe reality, and make intuitive, qualitative predictions about how things work that is most valuable. Now, when we think about it in terms of problem solving, what we're going to do is we're going to move from reality to the mental model by interpretation. We're going to interpret the problem. And as we interpret the problem, we're going to come over here and we're going to write our statement, our given, and our find in our homework format. So this is our interpretation process. And the whole idea as we copy what's given in the problem, as identify what we're looking for in the problem, is that we want to be observing reality and building that mental model where we qualitatively and intuitively understand what's going on. From the mental model, we're then going to move to our engineering and math models. And our engineering and math models are going to be quantitative and predictive. So the idea is that we can do some math and we can work some calculations and we can come up with numbers that predict how reality works. And the thing with engineering and math models is that they're simplified. They don't have all the jaggedness of reality, and they relate to our mental model, but they're going to be simplified in some ways, and they're expressed in the forms of like laws and equations and relationships like this. So often as engineering students, we think of the engineering math model as what the professor's teaching us. And that's true. We're actually pretty good at teaching this. But if you can just work the engineering math model, but you have no engineering judgment, no mental model, you're really going to struggle to come up with safe applications to shape reality. And so when we're thinking about our mental model, we're going to want to be able to identify those laws and equations in our engineering and math models, in our engineering science, if you will, that to let us do this. And this is our planning phase. And so thinking about our mental model as it relates to reality, we come up with appropriate engineering and math models, and we write down our procedure. So that's our planning phase. For example, if we were to do projectile motion, thinking about Nerf darts, right? We know that reality is that Nerf darts kind of scatter everywhere a little bit. Our mental model says that things like gravity is certainly going to affect it, but so will wind resistance and things like that, right? So that all matters, but we might instead end up picking a simplified engineering mathematics model that just accounts for gravity and neglects something else. And that's okay. And so when we do those calculations, we're always going to be, evaluating our work compared to that mental model. We got to think through whether or not the numbers that are coming out of our engineering and math model make sense. Uh, applying that engineering judgment, our mental model, as we actually work our solution. So here's where we're going to really work the solution. Often as students, we want to jump straight to the solution phase, but the important thing to recognize is we've got a lot going on. We've got to observe reality, understand it, build a mental model, and then identify the correct laws so that we can evaluate it. And then finally, before we make any claims about reality, we need to check our work. And so before we copy our answer, identifying those things we set out to find up in our statement, we're going to check our work and we're going to make sure that our reality, our mental model, and our engineering math models all align. The one thing that we're never going to do, don't do it. Don't ever, 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 just big old no, don't do it. Think that because you work some math, you know how reality is going to work. Your mental model can be informed by your engineering and math models, and they can be informed by observation of reality, but we need to work our way through that mental model and then back before we shape reality. And I hope you see how that walks us through our homework process of interpreting the problem, going from reality to mental model, planning our activities, going from the mental model to the engineering math model, actually working the problem as we evaluate our intermediate answers for reasonableness, and then finally checking that our correct answer matches what we would expect from reality. So this is the three models approach. Thank you.